can I interview you for math project? I think you'd be a really good candidate for this. Why don't you introduce yourself?
Hello, my name is
Hello.
Omar Vicente, and I am an electrical engineer, and I'm currently working in Texas Instrument with the gallium nitride products.
So you work at Texas Instruments, which is in Dallas, Texas. Um, so what do you exactly do as an electrical engineer? What type of job do you do? Can you please explain a bit more?
In my job, I am responsible to verify that new parts coming out from the development team. I am responsible to verify they work properly, and I do electrical measurements to confirm the behavior of the electronic devices.
Since you verify work and you make electrical measurements, what type of math would you use those in? Like, can you explain how you would use math in your work, line of work, or how you do things?
Um, Currently, I use math for mostly everything. We have the part that we're working are integrated circuit, so most of the device is inside the device. So we use math to predict the behavior of internal blocks, and sometimes it's hard to see the failures just by looking at the waveform. So we use statistics to be able to find when the parts are uh, out of the expected behavior, and also we use statistics to be able to have an idea what is going to be, do some prediction what is going to be the normal product coming out of the factory. We use math for also identifying problems in the part, and that's the main focus.
You use statistics and all those type of problems, and you say you have to find the main focus and what the problem is. How would you exactly put this, like, in a specific example? So, it's a bit easier to understand. What type of example would you be able to give us as, eighth graders, I guess?
So an example, let's say we got a new device. So the first thing that I have to do is make sure that it works as expected. So one of the tasks that I have to do is take multiple parts and collect the electrical measurements, and I'm going to compare them. So in the past, I worked with audio products, and it's very interesting because we didn't listen to the part to say they sound good. We were able to use math. In this case, we use a function called total harmonic distortion, and basically what the function does is it is expecting a signal shape, and it calculates the deviation from the original signal, and that is called distortion. So in my case, I was using numbers and signals to check the audio clarity of the amplifier without having to listen to it. And it's accurate because if I have to listen to it to say that it sounds good, it will be very different from person to person. But when I use math, the numbers are very descriptive because they doesn't change. It's not a point of view, it's not a preference, it becomes a number. So I can quantify how much distortion there was in the sound, and when the devices have very high distortion, I can compare with parts that are better with lower distortion just by looking at the data instead of listening to the part.
That's so cool. You just use math to see if it's correct or not, and it's perfectly accurate because it's just the pitch and it's like a correct pitch. You don't need people's ears and whatnot. This is so interesting. Thank you so much for being able to interview with me. Bye. Have a great day.